Kubernetes is an open-source platform for automating deployment, scaling, and operations of application containers across clusters of hosts, providing container-centric infrastructure. With Kubernetes, you are able to quickly and efficiently respond to customer demand, deploy your applications quickly and predictably, scale your applications on the fly, seamlessly roll out new features, optimize use of your hardware by using only the resources you need. Kubernetes can schedule and run application containers on clusters of physical or virtual machines. However, Kubernetes also allows developers to cut the cord to physical and virtual machines, moving from a host-centric infrastructure to a container-centric infrastructure, which provides the full advantages and benefits inherent to containers. Kubernetes provides the infrastructure to build a truly container-centric development environment. Kubernetes satisfies a number of common needs of applications running in production, such as co-locating helper processes, facilitating composite applications and preserving the one application per container model, mounting storage systems, distributing secrets, application health checking, replicating application instances, horizontal auto-scaling, naming and discovery, load balancing, rolling updates, resource monitoring, log access and ingestion, support for introspection and debugging, and identity and authorization. This provides the simplicity of platform as a service, PaaS, with the flexibility of infrastructure as a service, IaaS, and facilitates portability across infrastructure providers. Minikube creates a local cluster of virtual machines to run Kubernetes on. It is the simplest method to get your hands dirty with Kubernetes on your local machine. You can download the documentation for Minikube can be found at http://kubernetes.io/docs/getting-started-guide/minikube. To use Minikube, check this previous requirements on macOS, Keve driver, VirtualBox or VMware Fusion hypervisors. On Linux, VirtualBox or KVM hypervisors. On Windows, VirtualBox or Hyper-V hypervisors. VTX AMDV virtualization enabled. To check if virtualization support is enabled, run the appropriate command from below. The next command will output something if virtualization is enabled. Minikube is a single binary. Thus, installation is as easy as downloading the binary and placing it in your path. Use the next command to download Minikube. Next we will see several very useful commands to work with Minikube. To start a new cluster, Minikube start. This will create a new cluster of local virtual machines with Kubernetes already installed and configured. You can access the Kubernetes dashboard with Minikube dashboard. Minikube creates a related context for kubectl which can be used with kubectl config use context Minikube. Once ready, the local Kubernetes can be used. Kubectl run hello minikube image equals gcr.io/google_containers/echo server :1.4 port equals 8080. Kubectl expose deployment hello minikube type equals node port. curl $minikube service hello minikube, URL. To stop the local cluster, Minikube stop. To delete the local cluster, node new IP will be allocated after creation, Minikube delete. Kubernetes was originally developed by Google to power their container engine. As such, Kubernetes clusters are a first-class citizen at Google. Creating a Kubernetes cluster in the container engine requires cloud command from the Google Cloud SDK. To install this command locally, use one of the following options. Use the interactive installer, the easiest way for the newcomers. curl https://sdk.cloud.google.com, bash. execl $shell. Cloud init. Or you can download the SDK from https://cloud.google.com/SDK/ and run the appropriate install file. For example, to install in Linux, x86_64. curl log cloud sdk.tar.gz https://dl.google.com/dl/clouds/channels/rapid/downloads/google cloud. SDK 142.0.0 Linux x86_64.tar.gz. tar xvf. /cloud sdk.tar.gz. /google cloud sdk /install.sh. Cloud init. Once cloud is installed, create a Kubernetes cluster with cluster_name equals example cluster. Give to our cluster a name. num_nodes equals 3. Set the number of machines in the cluster. Cloud container clusters create $cluster_name num_nodes equals $num_VMS. A Kubernetes cluster is controlled using the kubectl command. The method of configuring Kubectl depends on where Kubernetes is installed. To install Kubectl using the Google Cloud SDK with the next command, Cloud Components install Kubectl. To configure Kubectl to control an existing Kubernetes cluster and container engine, Cloud Container Clusters get credentials $cluster_name. When using Minikube, the Kubectl binary needs to be manually downloaded and placed in the path. Use the commands that you see on screen. The Minikube binary automatically configures Kubectl when starting a cluster with the next command, Minikube start. After you have a running cluster, you can manage it with the Kubectl command. Most of the commands you can get with the Kubectl help command, but I show you the most common commands for manage and getting info about your cluster, nodes, pods, services and labels. For getting information about the cluster, you can use the following command: Kubectl cluster info. It will show you the running address and port. For getting short information about the nodes, pods, services, etc. or any resources which got a place on the cluster, you can use the following command: Kubectl get, nodes, pods, services. The output mostly one line per resource. For getting detailed description about the resources, you can use the describe flag for the Kubectl. Kubectl describe, nodes, pods. The deployed apps are only visible inside the cluster, so if you want to get the output from outside the cluster, you should create a route between the terminal and Kubernetes cluster. Kubectl proxy. It will open an API, where we can get everything from the cluster. If you wanted to get the name of the pods for getting information about, you should use the following command: Kubectl get pods go template range. Items. Metadata.name/nn. It will list the pods for later usage. curl http://localhost:8001 API/v1/proxy/namespaces/default/pod/pod_name/. Two other common command is the getting logs and the execute a command from / in the containerized app. Kubectl logs, pod_name. Kubectl exec, pod_name, command. Configuring tab completion for your shell can be done with source >kubectl completion zsh, # if you're using zsh. Source >kubectl completion bash, # if you're using bash. Or more programmatically, source >kubectl completion $0//. To finish this chapter, we are going to make a small example of how we can create the Hello World application. Once your Kubernetes cluster is running and Kubectl is configured, you could run your first application with a few steps. This can be done using the imperative commands, which doesn't need configuration files. In order to run an application, you need to provide a deployment name, the container, image location and the port. For this, run this command: Kubectl run bootcamp image equals docker.io/javatalon/kubernetes bootcamp v1 port equals 8080. Confirm that it worked with the command Kubectl get deployments. To expose your application and make it accessible from the outside, run Kubectl expose deployment /bootcamp type equals load balancer port 8080. To confirm that it worked with Kubectl get services. To access the services, use the external IP and the application port like this. Export external_IP equals $kubectl get service bootcamp output equals JSON path equals status.loadbalancer.ingress 0. IP. Export port equals $kubectl get services output equals JSON path equals items 0. spec.ports 0. Port. curl $external_IP, $port. Once this worked, you can scale up your application with the command Kubectl scale deployment /bootcamp replicas equals 4. And check the result with the next commands: Kubectl get deployments, curl $external_IP, $port. curl $external_IP, $port. Mind the changing pod ID. In order to push out a new application version, run the next command: Kubectl set image deployment /bootcamp equals javatalon/kubernetes bootcamp v2. And confirm it with curl $external_IP, $port. Cleaning up is finally done with the next commands: Kubectl delete deployment bootcamp, Kubectl delete service bootcamp. Well, with this we end this chapter on basic aspects of Kubernetes. Thank you very much for your attention, and we hope that it has been to your liking. A cordial greeting.